Okay, so in this video we'll look at the Linux standard permissions. So standard permissions are easy. We'll do this quickly. So in the context of Linux, there's three types of standard permissions. We've got read, we've got write, and we've got execute. So these can be represented with an R, okay, lowercase r, a lowercase w for write, or a lowercase x for execute. So we normally say R for read, W for write, or X for execute. If we're using the octo form, R can be represented with a 4, write can be represented with a 2, execute can be represented with a 1. If you're giving no permissions at all, okay, so it's just blank, this can be represented with a 0. So reading simply means that the file can be opened, okay, and this is normally for files that that don't have source code or any instructions to be run. So like a text file, a Word document, a picture, things like that. If you give read permissions, it means they can be opened, they can be accessed. For execute permissions are more like read, but for files that have to do with execution. So if it's a program, or if it's a script, or anything that can contain instructions that are meant to be run by the CPU. So then, for those instructions to be able to run on your computer, it needs execute permissions. So when you install a program, for example, it needs execute permissions. Write means that you can edit or change the content of the file. So if it's a Word document, it means you can open it and change what's inside there. Reading just means you can open it and view it. Writing means you can even be able to edit it, to change the contents. If it's placed on a folder, it means you can also add things to the folder or remove things from the folder. So same thing with execute. If execute is placed on a folder, it means that within that folder you can access even the subdirectories, not just the folder itself, but even the subdirectories or the subfolders that are there. So these are the three types of permissions. We'll show how to work with them in CentOS just a moment. This can work on pretty much any version of Linux. So when working with these permissions, we need to know three groups. Okay, so the user, the group, and others. So the user, the group, and others. So when writing permissions, we will always be giving, or maybe let me not say always, but we will normally be giving based off of these three groups. So the user refers to whoever owns the file, the account that owns the file. Okay, so that's the user. So meaning permissions that are given to the account that owns the file. The account that owns the file could be the account that created it. Maybe that's the one that downloaded it. They brought it onto the system. The group, okay, so every file belongs to not just an account, but also a group. A group is a collection of accounts, so it's meant to be a collection of accounts. It can contain many accounts. So for example, if you say we've got a group called students, students can contain Sweshi, they can contain Elijah, they can contain Ethel. Okay, so these could be accounts on the system or belonging to the group called students. Okay, So this means if we give the group students permissions, then in short, we're giving these three accounts the permissions. So that's what we mean by a group. So we mean a collection of accounts. So every file will belong to a collection of accounts. Then others refers to every other account on the system. Okay, every other account on the system. So this is in reference or in relation to the user and the group. So if you are not the owner of the file and you do not belong to the group, then you are considered an other. So to give a better illustration here, I would say, for example, my account, let's say, is Sweshi, okay, or let's say these are the accounts on the system. We might have Sweshi, Elijah, Ethel, we might have guest, okay, and maybe we might have Philip, okay. So all of these, let's say these are accounts on my system, okay. So if, let's say, Sweshi downloads the file, okay, if Sweshi downloads the file, so it means that, let's say we've downloaded a Word document, okay, so word.doc, okay, so this means that this file is going to be owned by account Sweshi. Then Sweshi's default group or Sweshi's start group, that's also going to be the group it will belong to. So normally it will also be called Sweshi. So every account has a group with the equivalent name. But I might change this, and so I might pass it on to student, right? So that the permissions are given for Sweshi, Elijah, and Ethel. Then the others in this case would refer to the guest account and Philip. Okay, so this is just for standard permissions. So now this is how you should think of it. So the account, the owner of the file, the group, normally it's going to be the default group for the account that brought in the file. So normally it's going to be Sweshi as well, because for every account there's a group name. For every standard account that you create, there's a group with the same name. But we can change the group to something else. So like in this case, the group can be set to students, right? Then every other account that doesn't belong to students or is not Sweshi will be considered another account. So then how do we change these permissions? So changing the permissions is pretty straightforward. So now I'll go to the Linux terminal here. So first of all, to check permissions, we can say ls, and just log on. We can say ls -l. So -l long listing will give us permissions in addition to other information. So we can see here, for example, the example.txt. We can see there's rw minus, these are 3 locations. So the 3 spaces are for the user, then the next 3 spaces are for the group, then the next 3 spaces are for the others. The first one, we don't count that one out because this one shows us whether it's a file or a directory. If it's a folder, it will have a D, okay, meaning it's a directory. If it's just a file, it will have a minus, meaning it's just a file, it's not a folder. Okay, so we start from the second one. So in this case, we start from ARA here. Okay, so we say RW minus, so that's read and write for the user. Okay, there's no third option, so there's no execute permissions. So The way we should read that is the user has read and write and nothing else. Then the next three, okay, the next three, it's error minus minus. Okay, so meaning there's only error for the group, meaning the group only has read permissions. Then the last three for the others only have error because it's error minus minus. So error minus minus means there's only read permissions for the others. We can do this for pretty much every other file, and you'll be able to see that that's how it works. You can see here the user and the group for that specific file. Okay, so meaning the root user is the one that's getting error w minus, and the root group is the one getting error minus minus, meaning this root group is getting that. Then every other account on the system gets error minus minus. If we analyze the Anaconda kickstart file here, we can see that we have read write for the user. The group 1, 2, 3 has got nothing. The others 1, 2, 3 have got nothing. So let's try changing some of the permissions. We'll work with this example text file here. So there's two ways of changing the permissions. So we can use the standard way of changing it or the octo way of changing it. So the standard way is maybe straightforward for people that don't like to work with numbers. Okay, so in the standard way of doing it, we can say chmod, okay, and then we can pick either the user, the group, or the others, or a combination of them, like a user and group and others, right? Or a group and others. Okay, so in this case we'll pick a user, so we can say chmod user. Then if we are adding permissions, then it's a plus. If we are removing permissions, it's a minus. So in this case, let's say we want to give the user read and write permissions. So you can say chmod u plus rw for read and write, and then the file would be example.txt. So this would be adding read and write permissions to the user. Okay, if we want to add to the group, we'll change that to G. If we want to add to the others, we'll change that to O. Okay, lowercase. If we're removing, we'd say minus, remove rw, okay, or remove r, or remove x. Okay, so let's try this out here. Okay, so we'll try changing it on the example.txt. So you can say chmod. So what we shall do is, for the user here, we will add an x. Okay, so we'll add an x permission for the user. So you can say chmod u plus x. Okay, meaning user plus execute permissions, then example.txt. So when we run that, then we do ls minus l again. We should check and see that the x will show up when we see that file. So you'll be able to see that that has happened. Error wx. Okay, so we can do that for the group, we can do that for the others. So you can say chmod. Okay, so let me give write permissions to the group and others. So the group and the others, we will add, so go group others, we will add write permissions. Okay, example.txt. So meaning I've added a w or a write permission on the group and on the others. So when I check it this time, I expect to see rw and rw on these two, on the last two, rw. So we'll say ls minus l, and we check, we see that this is what has happened. we added the write permission. They both already had the read. Okay, to remove those permissions, we can just bring back the command. Okay, chmod group others minus example.txt. Okay, so when we do minus, then it will take away and it will leave them with just read permissions. So what we've done is we have removed the W from these two. Okay, remember these two here. The group and the others have RW right now, and then when we run group and others minus W, then it means they're only going to remain with read. So when we do that, this is exactly what we see. It just has read on both of them. So that's the common way of doing it. If you want, you can use the numbers. Okay, remember we have them represented as numbers as well. I prefer to use numbers actually. So read is 4, write is 2, execute is 1. If you're adding no permissions or you're setting it to nothing, then it should have a 0. The only thing is you have to write this for every one of those three: the user, the group, and the others. So for example, read and write represents RW, which is a 4 plus 2. This is a 6. Read minus minus, meaning just the read permission, that's a 4. So we'll put a 4 for the group. And then read minus minus, this refers to just the read permissions on the others. So this is a 4 as well. So when we say 644, we mean ARA, W, ARA, ARA. Okay, so let's try this. So first of all, let me clear, and then we'll come back here. So what we'll do is we will change this one here to ARA, W, ARA, ARA. So we can say chmod 644 example.txt. Remember, 6 is 4 plus 2, 4 is read, 2 is write. So we expect the user to have read and write. 4 is read, 4 is read. Okay, so we'll do that and say ls minus l and see that it gives us RW minus ARA. Okay, so for the group ARA and for the others ARA. If we wanted everyone to have all of the permissions, for example, we can say chmod 777. Okay, 777 example.txt. Okay, so this means the user gets read, write, execute, the group gets read, write, execute, the others gets read, write, execute, which is not what you want in real life because that's dangerous. We don't want everyone to be able to do everything to any file. Okay, so this is what we've done here. RWX, RWX, RWX. Okay, then we'll say chmod. Okay, so I'll leave it at 644 example.txt so that we have what we initially had. Okay, RW, RR. Okay, so that's pretty much what you need to know about standard permissions in Linux. Thank you for watching. Like the video, leave a comment, subscribe to the channel. If you've got any questions, I'll definitely respond.